Hey, what's up guys, my name is Cherno and welcome to episode 8 of the Sparky Game Engine series. So today we're going to be talking about making a renderer. Last time we created all of these beautiful buffer kind of methods, right? And what we'll do today is actually use them in a renderer, okay? So to set up our renderer, if I go back to last episode's drawing board, we had all of this cool stuff and we talked about how everything works, and we talked about the fact that a renderer will basically be responsible for rendering renderable 2Ds, okay, which are these things, which have all this stuff like position, size, color, and from then on they will construct their own vertex buffer, index buffer, color buffer, all that cool stuff, all right? So to get that stuff to work now, we need to implement a renderer, some kind of renderer that does it. So what we'll do, what our plan is here, is to basically implement this renderable 2D, which will be essentially a sprite is some realization of that kind of interface and that kind of, I guess, superclass, right? And then our renderer 2D, which will have submitted flush, so we can submit renderable 2Ds and they will get rendered. And then submit will put them into some kind of queue and it will work like that. So it should be really good. So let's get started. So under graphics, I'm going to make a new item called renderable, and this will just be a header only kind of thing, renderable 2D. Alright, so this is something that, one thing I should probably mention, by the way, is previous episode, when I was testing this, I just bound IBO twice without actually unbinding it, so we should have probably done that. And actually, one more thing I want to mention quickly is that, we did all this cool stuff last time. I forgot to say that, obviously, with being able to set colors per vertex like we were doing, we can do some pretty cool stuff where we mix up, say, the colors, and we can do some pretty cool stuff where it, does, as you can see, that color is like more of a gradient, right? So we could have done some cool stuff like that. I should have probably demonstrated it, but I did not. So, I'm demonstrating it's now. So, how's this? Pretty cool, right? So anyway. That being said, back to our renderable 2D. Pragma ones. So as we noted out on our drawing board, we should have a submit and a flush, right? In our renderer. But in our renderable, we should have position, size, color. We probably won't worry about textures just yet since we don't have textures yet. And we should have a vertex buffer and index buffer, probably a color buffer as well, right? For those colors. So let's get started. We'll have our namespace. And I explained all of this last episode, by the way, so I explained probably more last episode than I should have, so anyway, so we won't really have private, we'll just have protected things. We shouldn't really need private things. So protected we'll have, so we'll need to include all of our maths stuff. So this will be in, I think just math, right? Maths, yeah, maths. Alright, we'll also need to have glued, and this is just for the reason of, oh sorry, no it won't. By this I meant to say we'll need to have our buffers. So buffer.h, index buffer.h, and vertex array. Okay, so we've got all this cool stuff. So what we do need to have is maths vec2, so size would be an example. I guess I'll just make this m size. We'll have a maths vec3 position, and again it's a, even though it's a renderable 2D, we're having a 3D position just because of the z value which we want to use to control the rendering order. Basically what's in front of what. We still want to be, even if we're 2D, we still want to control what is in front of what, so that's what that third coordinate is for. And then the color will be just a vec4. Alright, cool. So we've got, these are the actual things we store, but we also need to have a buffer called mColor buffer. We want to have a buffer that is mVertex buffer. We want to have vertex array, mVertex array, and we want to have index buffer, mindex buffer. So a lot of crazy stuff we've got here. So So out of this stuff, what needs to be constructed? Let's see. Buffer does. Okay, what we'll do is we'll actually have them all on the heap. And I think what we'll do is, yeah, so I don't think we actually need vertex and color buffer, because we're just going to send them off into the vertex array anyway. So yeah, we won't have that. So we'll just have a vertex array and an index buffer, okay? So when we actually create a renderable 2D, so renderable 2D, this will probably be a protected constructor as well. So we'll probably pass in something along the lines of, so we'll need, okay, so we'll just say we need a position, a size, and a color, right? And we'll control this through sprite a bit differently, but in fact we can just say vec4. We'll just say vec4. No, it won't. That's what sprite will do. Back we go. Okay, so size. I don't know why I called it m position. Position, size, and color. All right. So this constructor, apart from just doing all this cool constructory stuff, like this. In fact, I'll just do that here. We'll just do them all in a row. Size, size, color, color. Okay, so let's create a vertex. So a vertex array is pretty simple to create, and index buffer will be basically the same for everything. We could make this static. It's up to you whether or not you want to. We'll keep it not static now just to prove a point, and that point being the fact that these can have different index buffers rather than using one. We'll probably do both, actually, to be honest. So this will be a GLU short indices. Okay, we'll pass in indices and 6 into here. So renderable 2Ds will have the same kind of shape here. Okay, so we'll go ahead and that looks pretty good to me. I think we've made pretty much everything we need to make here. So we obviously want to have methods such as mathsvec3, probably const mathsvec3, get position, which will return m position. We'll make them all inline as well. We might have to force them to be inline, but we won't worry too much about optimization yet. This is episode 8, isn't it? So episode 10 will be the maintenance / optimization episode, which we'll have to talk about. What do we have? Size, position, color. Okay, cool. There we go. So now we've basically made this pretty good. So at the moment you can't change this stuff. If you remove const, you will be able to change this stuff. So it's not too difficult to do that if you want to. But anyway, it should be good anyway. If we do that stuff, we'll have to construct it anyway that way. So I don't really want to do it that way. Let's make sure that we do two things. Let's make sure we actually push the vertices and whatnot. But to create the vertices for our vertex array, we need to go ahead and go glfloat vertices equals. Okay, let's see. So we basically want to go through position. So 0, 0 will be the first vertex. Then we'll go ahead and say position dot x. Which way are we going? We're going clockwise, weren't we? So we'll just do 0 position dot y 0, and then position.x, and then position.x 0. So that's our vertices done, okay? Let's also do our colors. So we'll go color.x, color.y. We probably could give aliases to these and say, and make color.rgba as well. So in other words, we could give vec4's RGBA, but we won't do that now. We could do that using, say, a union or something, by the way. But anyway, there we go. Everything's good in the hood. Now that we've got these things, we can go ahead and say vertex array dot add buffer. So the first thing we want to add is probably a what's the pointer? That's right. Is we want to add a new buffer, being the vertex one. So let's add in the vertices, and the count will be what is it? Well, it'll be 4 times 3. The component count will be 3, and is that all we need? Oh yeah, and then here we need the index. Okay, and then we're adding the colors. 4 times 3. So 4 times 4, 4, and then 1. Same as what we did in main, right? And I explained that in pretty good detail there, I think. Anyway, so now that we've done all that, we need to definitely set up a destructor, which deletes vertex array and, oops, vertex array. Let's mark this virtual, obviously, and index buffer. That's it. Yes. Okay, cool. There we go. So we've got a pretty good renderable 2D class now that sets up all of this stuff, hopefully flawlessly, and it looks pretty good in general, I think. I guess we'll see. Okay, cool. So let's actually make that sprite now. So we'll make a new item. We'll make a actually, you know what? We don't need to really make the sprite right now. Let's make the renderer. Let's make the renderer. So renderer2d.cpp and renderer2d.h. Okay, so a renderer2d is going to have. So this is going to be this is just going to be a superclass. So we're not going to do stuff in here such as actually implement it. Okay, this will just be a superclass because there'll be multiple renderer2ds that we'll do. So we'll have our namespace of glory. That's its official name now. Namespace of glory, which Visual Studio keeps trying to correct. So renderer2d will have the following things. It will have so it'll have it'll probably almost all be protected, but really all it will do is it will have a void submit, which takes in a renderable 2D. Okay, and it will have a, I don't know why I did that, and it'll have a flush. So these are going to be pure virtual methods, which means that when we actually extend this class, we'll be forced to implement it. And also we won't be able to actually instantiate this class, okay? But that's the idea. So it's just something that keeps us in check, kind of. So include renderable 2D. All right, cool. That's the idea. I'm not sure if I actually want to take in pointers here. As in if I want to take, yeah. I guess so. I mean, let's just think quickly. Do I want to have references? Submit. Let's think. I don't think so. I think I'll just take in const references. Okay, that should be pretty good. Anyway, this is our renderer 2D, so we don't actually need a CPP called that. We'll rename the CPP to be called simple 2D renderer. Okay, and then we will steal that file name, and then we'll make a .h file for it, header file for it. Okay, so anyway, let's copy and paste this quickly. So this will, and then into renderer 2D, I'll also include other stuff we may need, such as OpenGL and our maths library. Okay, so let's go ahead and that's all good. So let's include our renderer. No, not that. Sorry, our simple renderer, which is this. So in here, I'll include renderer 2D, okay? And then this will be simple 2D renderer. So inside here, we'll have a few things. First of all, we'll have a queue. So the queue implementation we're probably going to use is a double-ended queue. So double-ended queue, just like that, okay? So we'll make that here, the queue, and it will be a queue of const renderable references, of course. So const renderable, renderable 2D, and we'll call this render or m render queue. Okay, we'll have these methods will be public. We should have probably made the other ones public, but whatever. If we mark them as override, it will correct us if we're wrong. So that's nice. So in this case, we need to make it public. All right, and then flush, sorry, will be right. Okay, so we need to obviously derive from our renderer 2D. Okay, so there we go. Now we're overriding them properly. Let's have we don't really need to have a constructor, I don't think. Really, all of this is going to be quite a simple class, right? If we just grab these things, this is going to be, as I said, quite a simple renderer. But really all we're doing is, when we implement this stuff in our simple 2D renderer, why did you get rid of that? Okay, when we're doing stuff like this, let's take a look at what this is doing. Literally, all this is doing right now is it's hitting up mRenderQ dot pushback, right? Renderable. Okay, that's all that is doing. And then when we come on to flush, that's where the magic begins. So really, again, this is called a simple 2D renderer because it is a simple 2D renderer. All it's going to do is it's going to basically say while our mRenderQ, right, dot empty is false. So as long as the queue is not empty, then what we need to do is basically call, let's just say renderable 2D. So const renderable 2D reference renderable is going to equal mRenderQ dot front. Okay, so we've got the reference. We're going to go ahead and go renderable dot. Okay, so this is at this point we need to actually grab all the stuff. I think I forgot to add most of all the stuff that we needed. So we've got the get position, but we don't actually have these vertex array and buffers. So let's make an inline, I guess const vertex array get VAO, which will return vertex array. Make sure it's a pointer. And then IBO, get index buffer object, which will of course return an index buffer pointer. Index buffer. Okay, cool. So back here now, we want to go ahead and call renderable.getV. Oh, work with me. Get. Okay. Why are you sad? Get VAO.bind. Oh, this is just so sad. Inaccessible. Oh, well, that's probably my fault. Yes, it is. So let's make this stuff public. Okay, back here. Okay, so we're binding it. Let's not forget to unbind it. So this is what Flush does. So it's going to draw everything step by step. It's going to bind it. It's going to bind the renderable.getIBO and unbind it at the end when it's done. Okay, and then it's going to basically go ahead and say GL draw elements. Let's see. So GL triangles. Count is going to be renderable.getIBO get count. Type is going to be GL unsigned short. And then 0, because we're not 0 or null pointer or whatever you want to pass in there, because we're not actually going to be specifying the indices. They get bound instead. Cool. So this is perfect, except for the fact that it doesn't actually address our, like, how should I say this? It doesn't address our current position. So what it needs to do is probably get the current shader that we're trying to use and bind it and use it to position the actual object. So in other words, we bind the shader outside of this, but it needs to actually push to the current shader, preferably like our position, because right now this is, remember, this is all of our size stuff. If we go back to our Renderable 2D, you can see that the way that it calculates size and whatnot is using this model matrix that it does. Where am I? Renderable 2D, right? So yeah, so we've got this position, but you can see we don't actually use position anywhere. I'm an idiot. Sorry, I meant to do size here. We're not actually using position anywhere, right? Because we're going from 0, 0. If we wanted to, we could have just done, say, position.y plus size y and done this for all of the other things, and then that would work. But remember, I want to be able to move these around freely, so I don't really want to do that. So at this point, we've got two options. We could either make a shader inside here and then simply grab that shader and use that or whatever, or we could just do it to the current shader, for example. So there's a lot of stuff we could do. I think I'm just going to do it to the current shader or something like that. So, or a shader that we pass into Flush. There's just so many different ways we could do this. So I think what we could do, though, if we were really nice, is probably do something along the lines of, this will probably be better, actually. So shader, I'll call this M shader, okay? So this shader, which we'll have to include, graphics, we're already in graphics. So just shader. When we do this, we'll make a, I guess we'll just specify a shader as well. This is going to be a, it's not going to be const. Okay, so shader, and then so this isn't a shader that we actually manage, so I think we'll probably just make this a reference to a shader. So M shader. Okay, so this is not a shader that we manage ourselves. This is something that we include from the other thing, and it will just totally handle it for us. And then of course we want a get shader as well. So inline not const shader get shader, which will be const, and return M shader. Okay, cool. So now in our simple 2D renderer .cpp, we can go ahead and say, based on the size, we can go ahead and say, we could keep this as a main, there's so many different ways to do this. We could say renderable.getShader, right? Set uniform mat 4. So at this point, we could just say we want to set the model matrix to maths, mat for translation, and then render. I think I'll just do it this way. So in this case, we're reconstructing the matrix every frame. Probably not the best thing to do, but you know, whatever. Renderable dot get position. All right. So we can do something like that. That's totally legit, and then that will actually set the model matrix to be whatever our thing is, and that looks pretty good. That's actually legitimately it. That's all we need to do. So it's pretty simple. That's why it's called a simple 2D renderer. But it should get the job done pretty well, except again, we need one draw call per renderable, which is a bit, but that's okay. So let's go ahead and make that. Did I make the constructor private or protected or something? I think I did. Let's not do that. So in renderable, let's make this, in fact, I think everything should be public, yeah. So we'll just make this public and we'll get rid of this public here. So back out here, right now what are we doing? We're doing all this stuff. I'm going to just delete pretty much all of this because we don't really need it anymore. I might keep it here just for reference because I kind of want to do the same thing, don't I? And then all this mess I'll just get rid of. Okay, so what I'll do here is up top, I'll go ahead and create. So what do we want? We want two things, right? We want graphics, we want a renderer 2D, and then we want a renderable 2D. So go ahead and say over here, for example, create a renderable 2D. We'll call this our sprite, for example. So what do we need for this? I wish you would help me. We need a position. So we'll say maybe 0, 0, 0. Oh, we'll do something more fun. 5, 5, 0. Then we need the size of this. So the size will be like, what was the other size stuff that we had? Oh, it's like 8-ish, 4. We'll make it 4. So 4, 4, 4, for example. The color will be pink. Why not? It's a good color to test things. And then the shader will be the shader. So we don't actually have one yet, but it's going to be this. All right, cool. So there's our sprite. So if we want to render the sprite now, let's construct the renderer 2D. So, well, yeah, you can just go renderer 2D, renderer, and then we'll, no, we won't do that. We'll go simple 2D renderer, which is an implementation of renderable, which is an back you go, up. So simple 2D renderer. Renderer, and then we'll just call renderer.submit our glorious sprite, and renderer.flush. Yeah, so let's see. This is the moment of truth. Let's see if it works. Build errors. Okay. So what up? Pointer to reference is illegal. What's going on? Whoa, this is mean. Pointer to reference is illegal. Oh, does it not want us to use references? I think it might not want us to use references. Okay, we'll use pointers then. Let's go back to our simple 2D renderer. So we'll make a queue of why does it not want us to use references? Of const 2D pointers then, I guess. And then out here, we'll do the same thing. So we'll take in we'll push that in. We'll have to go back here and make this totally acceptable. And then we'll have to make this a pointer, and then we'll have to change all of this stuff to be this. All right, you happy now? So now we'll have to okay, submit has no, okay, yeah, So let's go back to renderer, change that to that, and then when do we submit it? Let's submit it like that, I guess. Okay, it's happier. It's happier, but we're also not responding, so that's also great. That's probably because we're not removing it from our queue, are we? I think I forgot to do that. I did. So once we do all this stuff, once we do go render queue.front, you have to make sure that we actually pop the front of our queue. Okay, otherwise whenever we're removing elements for it, and this while will be just completely good. So there we go. So it looks like it's working. We're probably at about 5.5, right? So it looks pretty good. So that's one sprite, and it's pink. So that's all totally the best, it seems. So let's create more than just one sprite. Let's go ahead and so where are our sprites? So that's one sprite that we've got. Let's create another sprite at 5, 1 or 7, 1, and we'll make it a bit smaller and a bit wider maybe, or a bit taller, and we'll make it some other color, like maybe let's make it like let's make it kind of bluish like that, right? Let's call it sprite 2, and then let's actually submit it. What did we? Oh yeah. Okay, let's get rid of all of this stuff because we no longer need it. Much better, much more breathing room. So we've got our sprite and sprite 2. Cool. So it seems to work pretty well, I'd say. That light is pink, which is a bit weird, but I'm not going to look too much into that because I'm sure that's something to do with our lighting calculation. Anyway, this looks pretty good, and it looks like everything is working fairly well. So there we go. So now we've got a simple 2D renderer. So we just submit things to it, and it does its work. So if you guys have any questions about that, leave a comment below. Anything else I wanted to mention? I don't think so. So yeah, next time we will. We'll move on to a more complicated renderer, probably that does things. We might clean a few things up in this renderer first, but we'll probably move on to more complicated things. And yeah, so if you guys enjoyed this video, please hit the like button, and I'll see you guys next time. Goodbye.